Welcome to this video on solving proportion word problems. Let's begin. When setting up word problems, the important thing is to always make sure the same quantity stays on top. For example, let's say the ratio of apples to oranges that Josh buys is always the same. One day he buys 4 apples and 3 oranges. If he buys 8 apples the next day, how many oranges will he buy? When we set up a proportion, if we decide to put apples in the numerator in the left-hand fraction, then apples must also be in the numerator in the right-hand fraction. So we would have 4 apples over 3 oranges equals 8 apples over some number of oranges. That's what we're trying to find out. So I put a question mark there, you can put an x there, and solve for x. Okay, conversely, we could put oranges in the numerator, it doesn't matter. But if we do put oranges in the numerator in the left-hand fraction, then oranges have to stay upstairs in the right-hand fraction. So in this case, then we would have 3 oranges to 4 apples equals question mark oranges to 8 apples. Again, the bottom line is it doesn't matter which value goes in the numerator and the denominator at first, as long as you're consistent and it stays that way throughout the problem. So I just want to prove to you that this is true and that, again, it doesn't matter which one is which. So in this case, we would have 4 over 3 is equal to 8 over x. Then we would cross multiply. We would get 4x is equal to 24, divide by 4, and we would find out that that next day when Josh buys 8 apples, he's buying then 6 oranges. Okay, same thing here. Oops. Right, if I cross multiply, I still get 3 times 8 is equal to 4x, or 24 is equal to 4x. So you can clearly see, since I end up with the same equation, of course I would end up with the exact same number of oranges in either case. Okay, so again, doesn't matter which one goes upstairs or which one goes downstairs, as long as you are consistent throughout your problem. All right, so let's get into an actual example. So this says, assume that property taxes are directly proportional to the property value. So let's think about what that means. Your property taxes is the amount of money that you pay the government, right, for owning a property. Okay, so it's saying that they're directly proportional to the property value. What does that mean? Well, it means that if you own a property that's worth, let's say, $200,000, right, that your taxes are going to be less than a property that was worth $1 million, right? The more your property is worth, the more taxes you're going to have to pay on it. The less your property is worth, the lower your taxes are. Now, there's obviously other variables, right, like where you live. If you live in the middle of nowhere in South Dakota, your property taxes are going to be much lower than, the city of Annapolis, right? Very different. Okay, but in this case, we're just considering these two things. So it says the first thing we need to do is identify our quantities. So again, the first quantity we have property taxes and property values. So remember, it doesn't matter which one goes where, right, as long as we're consistent. Okay, so I'm going to call property taxes PT. I'm going to call property value PV. Okay, so I'm going to keep it that way throughout my whole equation. Okay, so it says a $300,000 property. Is that my property value or my property tax? Well, that's the value, right? So that's this guy down here. The property value is $300,000. Okay, so I have a $300,000 property value. Okay, they pay how much? They pay $6,000 in property taxes. So should I put that upstairs or downstairs? It doesn't matter. Okay, I can put that above the $300,000 or below the $300,000. It doesn't matter. I'll just stick it down here below. Okay, as long as, right, I'm consistent on the other side of the equation. Okay, so the value is $300,000. I have to pay $6,000 in taxes on that property. Okay, so here's the important part. This is the really critical part. I have to make sure that the property value goes upstairs on the other side and the property taxes goes downstairs on the other side, right? So the property value, he's upstairs, he stays upstairs. Tax downstairs stays downstairs. Okay, so be careful with that. Okay, so then they're saying $500,000 property. So again, that is the value of the property, not the amount of taxes. Good grief. I don't know how much it would be worth if you paid $500,000 just in taxes. That would be a very expensive property. Okay, so we have $500,000 property value, and the question is how much would you have to pay in taxes, right? That's the unknown quantity, so we just throw X there. Okay, so now hopefully you can see this is a very boring, simple equation, proportion, right? And of course we can simplify it by crossing out some of these zeros here. That might help us a lot, right? So if we cancel out 1,000, we actually get 300 over 6, excuse me, is equal to 50,000 over X. Okay, you don't have to cancel out if you don't want to. It just saves you a little bit of bother. So then we cross multiply and solve. Okay, so 6 times half a million is 3 million. So we have 3 million is equal to 300x. Divide by 300, divide by 300. Okay, so we cross 3, 0, 0. So we end up with $10,000 in property taxes. Okay, so let's go back to the original problem and see if this makes sense. Okay, so if I had to pay $6,000 in property taxes on a $300,000 property, right? Let's just double that in our minds, right? So if the property was worth $600,000, then I'd have to pay $12,000 in taxes. So you can see that $10,000 is slightly less than $12,000, right? And $500,000 is slightly less than $6,000. So this makes sense. It feels that it could be true, right? If you have to pay $6,000 on a $300,000 property, it could be true that you pay $10,000 on a $500,000 property. Okay, and again, the ratio is the same. So that's it. That's how you set up these problems. All right, let's do another example. So this problem says the amount of savings you experience is directly proportional to how much you spend. So savings and spending. Okay, so I'm going to just say there's savings, I'll call it SAV, right? And then there's spending, I'll call that SP. Okay, so Susie spends $300. Okay, so let's write that down. She spends $300. Okay, she saves, or her discount is $60. This is my savings. Okay, again, it doesn't matter which one goes upstairs and which goes downstairs as long as you're consistent. Okay, so on the other side, the spending has to go upstairs too. The savings has to go downstairs too. Okay, then it says Jenny saved $80. Well, where should we put the $80? Should we put it up here? No, because she didn't spend $80. That's how much she saved. So where should the $80 go? The $80 should go down here with the amount that she saved. So we want to know how much she spent if she got an $80 discount. Okay, so we have 300 over 60 is equal to x over 80. You can cross multiply and solve, or if you want, I'm going to be a little bit lazy and divide. And then 30 over 6 is actually just 5. So this just saves me a little bit of time later. You don't have to do this. You can cross multiply first. It's up to you. Okay, so 5 times 80 is 400. X times 1 is x. So she spent $400 in order to save $80. It's still a pretty good savings though. All right, let's do another problem. This one says Sarah worked 10 more hours than Josh. So what are the two things that we're looking at? Well, the two things that we're looking at are the amount of time that Sarah worked and the amount of time that Josh worked. So I'll just use two variables here. I'm going to use S and I'm going to use J. Okay. Then it says if Sarah worked 7 hours for every 2 hours Josh worked, how long did they each work? So this is a little bit of different. Let's see if we can figure this out. So the first part says Sarah worked, so that means S equals 10 more hours than Josh. That's 10 plus J. Okay, so we have this one equation here. We're just going to set that off to the side and then move on with our lives. Okay, so then we know that Sarah worked 7 hours for every 2 hours Josh worked. So what does that mean? That means the ratio of Sarah's work to Josh's work is 7 to 2. So believe it or not, what we actually have here is a system of equations. We have two equations. Okay, so again, this is a little bit different from everything that we've been doing so far because, right, we have to solve this. So you can do this in a few different ways. You might think of a different way that I haven't thought of. What I'm going to do personally is I'm going to use substitution to solve this. Okay, so since s is equal to 10 plus j, I'm going to replace s with the expression 10 plus j. That's what I'm going to do. Okay, again, there's other ways to do it. If you want to see some other ways, feel free to see me in class or something. But this is what I'm going to do. Okay, so I'm going to use the substitution property of equality. Since s is equal to 10 plus j, I'm going to write 10 plus j in place of s. Okay, and then I have this nice equation here that I can just cross multiply and solve. Okay, so I have 7j is equal to 2 times the quantity, 10 plus j. Okay, so we have a little bit of work to do. We need to distribute. Okay, going to solve for j by subtracting 2j from both sides. The equation, we get 5j is 20, divide by 5, divide by 5. It looks like our friend Josh worked for 4 hours. Okay, so let's read this and see what they're asking us for and make sure that we answered it. Right, so it says, how long did they each work? Well, so far we only know how long Josh worked. He worked for 4 hours. How can we figure out how long Sarah worked? Well, we can actually use either equation to figure out how long Sarah worked. I think the first equation is easier to use. Sarah worked 10 hours more than Josh. Well, Josh, we just found out, works 4 hours, so she must have worked 14 hours. Okay, now we're done, right? We found both things that we wanted to. What we could do, if we wanted to, is we can go through and actually check our work. Okay, so let me show you that real quick. So I could use the other equation. So the other equation is s over j is equal to 7 over 2, right? So if I'm right, if Sarah really worked 14 hours and Josh really worked 4 hours, then when I cross multiply, I should get the same number on both sides. So let's see if that works. Well, 14 times 2 is 28, and 7 times 4 is 28. So this is correct. Okay, so I checked my work with the other equation, and I proved to myself that the values that I found are correct. All right, let's do one more example. So it says Computer Services Incorporated charges $8 more for a repair than low-cost computer repair. So this is kind of similar to the problem we had before. So I'm going to call Computer Services C, okay, and they charge $8 more than, I'm going to call it L. I'm going to write it as a script letter so it doesn't look like a 1, okay. So we have C is equal to 8 plus L. That's my first equation. Okay. Then it says if the ratio of the cost is 3 to 6, I don't know why they said 3 to 6 and not 1 to 2, what will it cost for the repair at low cost computer repair? All right, so we have 3 over 6 equals, now here's an interesting question. Which one goes where? Should it be C over L or should it be L over C? And how do you know? So if you want, pause the video, think about that question a minute, and then unpause it and see if you're correct. Okay. Well, the bottom number has to be the larger number, doesn't it? Right? So which one is more expensive, computer services or low cost? Well, computer services is more expensive because they're $8 more than the other one. So therefore, the L has to be the smaller one. By our logic, right? That has to be the smaller one, and C has to be the larger one. So this has to be true. Right? It doesn't make sense that the larger number over the smaller number would be equal to the smaller number over the larger number. It's not going to work. Okay? And if you don't believe me, you can try it and prove it to yourself. So I'm going to do the same way. I'm going to solve this the exact same way we did last time. So I'm going to have 3 over 6. If it's okay with you, I would like to just change this to 1 over 2 because it's just silly. Okay, so 1 over 2 is equal to L divided by, I'm going to use the property of equality here. So C is equal to 8 plus L. So instead of writing C, I'm going to write 8 plus L. Okay? And then, as always, we can cross multiply and solve. So we have 2 times L is 2L is equal to 8 plus L. Okay? So let me write that up here so I have some more room. Okay, so I'm going to subtract 1L from both sides. So if I subtract 1L from both sides, I find that L is equal to 8. Okay, so that means that they charge $8 for the repair. Since the other company charges $8 more, then they must charge $16 for the repair. Okay, so again, the low cost charges $8, the other company charges $16. Okay, now if you don't believe me, what you could do is you could try setting it up like this. You could try something like this. Let's just see what happens if we set it up the other way, if you really aren't sure, because I'm pretty sure we're going to get like a negative number. Okay, so 3/2 reduces to 1/2, and then we have 8 plus L over L. Let's see what happens when we do this. Let's see, this will be interesting here. So if I cross multiply, I get L is equal to 16 plus 2L. Okay. And then if I subtract 2L from both sides, I get negative 1L is equal to 16. If I divide both sides by negative 1, I get L is equal to negative $16. Hopefully you can see that really does not make sense in the context of the problem. That's like they're paying you in order to fix your computer instead of you paying them to fix your computer, right? That doesn't make sense at all. So again, if you try doing it that way, you can see that it's definitely most assuredly wrong and it's incorrect. You have to have the L, which we know is the cheaper option, right? That has to be on the top, and we know that the more costly option, 8 plus L, has to be on the bottom.